Right, so first, some key things about the polar coordinate grid. You notice it kind of looks like a spider web. And yeah, I don't like spiders either, so we'll just not talk about that. But so as you can see, we have circles that represent the common values of R, which more or less answers this first question over here. This one here represents all the points that are 5 units away from the origin. And remember, that's what R is distance from the origin. And notice that these lines here, I was going to draw a random one here, that line corresponds to the angle 5 pi over 12. So no matter where I am on that line, no matter what value of r I am, I'm always inclining 5 pi over 12 from the positive x-axis. So if theta equals a constant, that means you're always on that line. And if r equals a constant, that means you're always on that circle. So the key thing here is that we have a circle. I'm going to make up my own little acronym, centered at origin. And this is a line through the origin. Okay? Now the other question to consider is, what happens if r is equal to 0? We have a good idea what happens when theta equals 0, but if r equals 0, that means we have not left the origin, which means r equals 0 is just a way to describe a point. Okay? So there we have that. So with those things in mind, let's look at plotting a few points in polar coordinates. So you notice I have 10 here, so we'll just speed right through them here. So 3 comma pi over 6. Now remember, the format is r comma theta. So that means we're going 3 units away from the origin at an angle of pi over 6. So I tend to look at the angle first. So I know that I'm along the angle pi over 6. And I want to go 3 units away from the origin. So this is 1, 2, 3. So this point right here is A, and I'm going to get rid of the evidence right here. Okay, so that's A. B is the point 4, 0, which means 4 units away from the origin and an angle of 0 with the x-axis, which means I'm on the x-axis, and I'm going to go out 1, 2, 3, 4 units. So that's B. Okay, so we have A, we have B. C, notice that r is negative this time. So here's what that means. I'm going to incline pi over 2, which means I would normally be facing this way. But since r is negative, I'm going to go the other direction. So there's 1, 2. So that would be C right there. Okay? So r is negative means you're facing away from the angle that you're inclining. Okay? So there's C. D, 0 comma pi. Well, again, 0 being r, that means I'm just at the origin. So that could have been, pi could have been anything. We'd still be at the origin. So that's D. Okay. E, 2 comma 3 pi over 4, which means, well, I'll incline 3 pi over 4, which means along this line right here, and we'll go 2 units out. So that is where point E is. So we're halfway there. Negative 2 comma negative pi over 4. That's interesting. So negative pi over 4 really is this way, right? We go 45 degrees clockwise. But since I'm going negative 2, I'm going backwards. And notice that E and F are the same point. Interesting. We'll have to talk about that in a moment here. 1 comma 3 pi over 2. Well, if I incline 3 pi over 2, that means I am facing in the direction of 270 degrees. And that's actually right there. So that is point G. 4 comma 3 pi. Well, okay. 3 pi would mean I'm going around the world once and then 180 degrees. So basically 3 pi is the same as pi. 1, 2, 3, 4. So that is H. So just thing to notice about 4 comma 3 pi, it is in the exact same position as 4 comma pi. Kind of interesting to think about. 1 comma 5 pi over 6, so we incline 5 pi over 6 and go out 1 unit. So that would be right here. And that's I. And last but not least, J, pi over 4 direction, but negative 3. So pi over 4 means we go this way. But negative 3 means we're actually backtracking. So that would mean 1, 2, 3. And there we have it. So there's your 10 points in polar coordinates. Okay? So there's some things to realize about this. So if we're given r theta, here's some things that we know. So if I add or subtract 2 pi to the angle, it's the same as if I stayed at the same point. And let's think about that with any of the points that we plotted here. I'm going to pick point A here. If I would have kept the same r value but went around an additional revolution, I'd be at the same point. So that means that if I add or subtract any multiple of 2 pi, I'm still at the same point. So that means that there are many different representations of the same point in polar coordinates. Okay, now looking at r comma theta plus or minus pi, well, let's see what happens here. So looking at points E and F here, notice that those angles are pi units apart and the r's ended up being opposites of each other. Okay, so what that tells me is if I incline pi units, and again, I'm going to pick on point A here, that would mean I land right about here. I'll use a different color just so it's clear. That is the same line. Okay. If I made r negative, I would end up back at A. So what this means is that this is negative r comma theta. So what that means is if you add pi to the angle, you negate r. Okay. So those are some neat little relationships with polar coordinates. So thanks for watching that, and come back for more. We'll do some examples, and then we'll get to talking about converting between points, between coordinate systems, and converting equations between coordinate systems. So it's going to amp up here. Thanks for watching.